Imagine, this is a breakthrough world. A world. This is everything. And where tumors are being spotted, have nowhere to hide. Look closely. Misdiagnosis is a multi-billion-dollar problem. Until now, a new breakthrough AI just hit a staggering 99.3% accuracy, using powerful attention gates to spot anomalies instantly. And it's transparent. It shows doctors exactly what it sees. This is the future of life-saving medicine, happening right now. Let's dive into the tech that's changing everything. You don't want to miss this.
Okay, so today we're diving into something truly incredible. It's a new study about an AI that can spot brain tumors on MRI scans, and it does it with an accuracy that is just mind-blowing. This really could be a massive game changer for doctors and patients. Let's break down exactly how it works. So here's how we're going to break this down. First, we'll get into why this is such a tough problem to solve in the first place. Then, we'll look under the hood at how this new AI was built, see how it actually performed, and then, and this is the really cool part, we'll peek inside its black box. Finally, we'll zoom out and talk about what this means for the future of medicine.
All right, first things first. We have to understand the stakes here. Accurately mapping out a brain tumor isn't just difficult, it is an incredibly complex and critical task.
Right now, the way we do this is by having human experts, radiologists, painstakingly trace the edges of a tumor on scan after scan. And as this research points out, that's not just slow, it's also subjective. Two different experts might draw slightly different lines, and those small differences can have a huge impact on a patient's surgery or treatment plan.
And this slide right here gives you a perfect picture of the challenge. On the left, that's what the doctor sees, the raw MRI scan. On the right, that's the goal, a super detailed, color-coded map of every little part of the tumor. Getting from the image on the left to the map on the right is the whole ballgame, and it's exactly what this AI was built to do.
So the big question is, how did the researchers actually build an AI that could handle such a complicated job? Let's get into the nuts and bolts of this thing.
Okay, this chart shows the entire pipeline, from beginning to end. You start by feeding it a whole bunch of MRI scans. That data gets prepped and sent into the AI model itself. The model does its thing, makes a prediction, and gets scored. But you see that last step? That's the crucial part. They use something called Explainable AI so that we're not just getting an answer, we're understanding how it got there.
Now, the team didn't just grab some off-the-shelf AI. No, they made some really important upgrades. They started with a powerful design that's famous for image analysis, but then they added these attention gates to help it focus. They also fine-tuned how it learns, and, maybe most importantly, they built in a way for us to see exactly what the AI is looking at.
And this is the core of the model. It's called a U-net, and well, you can see why. It's literally shaped like a U. On the left side, the encoder, the AI kind of squishes the image down to understand the big picture features, the what. Then, on the right side, the decoder, it builds it all back up, using what it learned to draw an incredibly precise pixel-by-pixel map. The where. It's brilliant.
And here is the absolute secret sauce, these things called attention gates. The best way to think about them is like a super smart highlighter for the AI. As it's looking at the brain scan, these gates tell it, hey, pay more attention to this spot, it looks important. And you can ignore that part, it's just healthy tissue. That ability to focus is what makes it so incredibly accurate.
Okay, so the theory is sound, the architecture is clever, but the real question, the only one that matters is, did it actually work? Let's look at the results.
This is it, the moment of truth. After all of that design, all of that training, did this model actually deliver the goods?
The result was just staggering, a DICE coefficient score of 99.3%. Now, to put that into perspective, that score measures how perfectly the AI's outline overlaps with one drawn by a human expert. A score of 100% would be a perfect match. Getting to 99.3 is it's almost unheard of. This is a huge, huge deal.
And this chart just hammers that point home. I mean, look at this. On the two most important metrics used to measure this stuff, the model is scoring it incredibly close to a perfect 1.0. This isn't just good, it's top of the class, setting a new standard kind of performance.
And if you don't believe the numbers, just look at the pictures. On the left, that's the ground truth, what the human experts drew. On the right, that's the AI's prediction. I mean, come on, they are virtually identical. The shape, the boundary, everything. That's the level of precision we're talking about here. It's just incredible.
But here's the thing. In a field like medicine, getting the right answer isn't always enough. Doctors have to be able to trust the tools they use. They need to understand why the AI is making the decisions it's making. And that's where something called explainable AI comes in.
This is how we crack open that black box. Using a special technique, the researchers can create this heat map. It shows us exactly what parts of the image the AI was focusing on. And as you can see, all that bright red and yellow is right on the tumor. It's not looking at some random noise. This visual proof is absolutely crucial for a doctor to be able to trust the AI's output.
So, we've got breathtaking accuracy, and we have this window into the AI's thinking process. What does all of that really mean for the future of medicine?
Well, when you put this model's performance up against other recent top-tier models, it's not even a contest. That 99.3% isn't just a little bit better, it's a significant jump ahead of the pack. It really sets a whole new benchmark for what's possible in this field.
And that really brings us to a final, pretty powerful thought. What we're seeing here is AI evolving from just a tool into a genuine partner for doctors, a partner that's transparent, trustworthy, and unbelievably precise. It really feels like we've moved past the question of if this will be used in hospitals to how soon it will be an essential part of every single team.